This is the first tutorial for the chapter Similarity, and this is just a continuation of a very similar chapter you had in, I think, grade 9 or 8, I'm not sure. So similarity, the whole concept, right now we're dealing with triangles, so the whole concept is about how you can say that two triangles have the same shape. They might not have the same size, but they have the same shape. And then of course you'll be dealing with a few properties of those as well. Now, just to start off, another very similar term is congruency. I'm sure you've heard of this before. Now, congruency means something that is an exact fit. So say you have a triangle here. Now if that line is a bit too long, yeah, that's fine. Now if I select this whole triangle, I copy it, I paste another copy of it over here. Now these two triangles are exactly the same. I've copy pasted this triangle, so everything is the same. The size is the same, the lengths of the sides are the same, the angles are all the same, the area of course will then be the same. So this is called congruency. And this, I think you've done it last year. Congruency, the two triangles are then called congruent. Similarity, I'm going to paste another copy so I can use that to demonstrate similarity. So here I have a third triangle of the same copy as the other two triangles, but now I'm going to increase its size. It's 144 by 155. I'm going to double it now, so that becomes 288 by 310. Okay, so it's got blurred a little bit. That's because I've increased the size. That's fine. But now you can see that the area of this triangle at the bottom is definitely going to be more than the triangle on top. But if you look at it, the shape is exactly the same. All I've done is increase the size of the whole triangle. So say that this side here was called X, Y, Z here. I doubled it, hence this would be 2X, 2Y, and 2Z. Now let me just name the triangles so I can refer to them by the sides. A, B, C here, and let's say I've used X already, so let's say LMN. Now what you can see is that if you take the ratio of the similar sides, say, by that I mean if you place these two triangles together such that their shapes will be the same when you're looking at both of them, then you take the corresponding sides. For example, here I'm going to take AB, which if you look at the triangle, it's the side on the left hand side. Now if I look at LMN, the triangle, the side LM is on the left hand side. So if I take the ratio of these two, that is equal to, you can see over here, y by 2y, which is equal to 1 by 2. Just cut the y's and you will get 1 by 2. And if you notice, this is actually equal to BC upon MN. Same thing, the ratio between the other corresponding sides is also 1 by 2 because you're taking Z upon 2Z. And this again is equal to AC upon LN. So you can see here, for the two triangles to be similar, all three sides are in proportion. They're not the same, but they're in proportion. So you can say from this whole discussion that if for two triangles to be similar, they just need to have the same shape. They need to have the same angles. It doesn't matter whether the sides are half of those of the original, 5 times of the original. As long as the original shape is maintained, those two triangles will be similar. And that for that to happen, all three corresponding sides here need to have the same ratio. Here we have 1 by 2. They need to be in proportion. So now there are many ways to prove two triangles to be similar. First one is the most basic one. It's called angle-angle, and it's denoted by AA. These are called axioms of similarity. Now you have two triangles. I think you would have done these before as well. Two triangles over here. I should draw this one bigger, or let's say smaller. So I've tried to draw them similar. I know it's not exact, but just so you understand the concept. Now, if you can prove any two angles, say let's take this one and this one. If you can prove its corresponding pair, if you can prove that all these four angles, the two pairs rather, are equal, which means that these two angles are equal and these two angles are equal, then you prove that the two triangles are similar. Because what that also means is that the angle which is left out is also equal, because the sum has to equal to 180 of all the angles in the triangle, and so all their angles are the same. That's the first way. Second way is called SAS, which stands for side angle side. Now, there's a reason why we've written side angle side, and that the A is not on either side. A has to be between the two sides. So let's take another pair of triangles. So if you can prove that any two sides, let's take these two for example, two pairs of sides are proportional, not equal, but proportional. And I'm saying that because you can see that the first triangle is much smaller, but it's still the same shape as the second one. So if you can prove that this side here is proportional to this side here, as well as this side here is proportional to this side on the right over here, then, and also the third thing you need to prove is that the angle that the sides make in between them needs to be equal, not proportional but equal. So, and also don't get confused, just remember this as a sort of sandwich here. The two S's are sandwiching the A in between them. So you can't prove these two angles on the bottom left and say that are proved by SAS. That'll not count. You only can prove the two on top if you're taking these two sides. Basically, the angle that the two sides you're taking, the angle that both of them make with each other. And the biggest point over here, don't forget, we're talking about proving the sides proportional and not equal. That's very important. Otherwise, you'll be proving everything congruent, not similar. The third one is very basic again, SSS, side, side, side. In this, what you need to prove is that all three sides are proportional to all three corresponding sides of the other triangle. So I don't think I can explain much here. I think it's obvious. If you can prove that the three pairs of sides and they're all proportional, they're all corresponding to each other, then you prove that the two angles are similar. And note that this is the symbol for similarity. In case you're wondering where you've seen it before, you probably see it on the top left of your keyboard. This is a symbol, and you don't put an equal to sign. If you put an equal to sign, if you put an equal to sign, then that means that you're saying the congruent and not similar. So I hope you got the difference between the two. And I'm going to tell you just one theorem before I leave you and carry on in the next tutorial since I'm running out of time. There is a relation between when you have two similar triangles. Let's take change color here. Say you have these two triangles here, one bigger one, and you've proved already that they're similar. It doesn't matter by which one, whether it's AA, SAS, or SSS, you prove them similar somehow, or you've been given that they're similar. If you take any two corresponding sides, say I want to take this side and this side, and I take the ratio and I square the ratio. Let's name the side AB. Let's name the side LM, just like the first example. So I said we'll take the ratios AB by LM and square this whole ratio. That means you get AB squared upon LM squared. This is actually equal to the ratio between the area of the first triangle. I'm just writing area 1, I don't have space, upon area 2. Okay, so this will be true for any of the sides. I've taken AB over here. Say I name this C and I take AC. Say I name this N over here and I take Ln. I square AC and Ln, take their ratios. That 2 will equal to the ratio between the two areas of the triangles. And the same thing, like if you reverse it, say I take LM square upon AB square, then I'm going to get the opposite. I'm going to get area of second triangle upon area of first triangle. And the biggest thing to remember here is that this gives you the ratio between the two areas. This is not giving you the area. So you could even get your area ratio as 1 by 2. That doesn't mean that the two triangles are 1 centimeter square, 2 centimeter square. It just means that the ratio between the areas is 1:2. That's it for this tutorial. In the next one, I'll be continuing with one more theorem and then on to maps and models, which is very important.